Okay, now we're going to talk about what are called polyatomic ions. So there's still ions, which means they still have a charge, but this time, and you guys might recognize the prefix poly as meaning many. In this case, it could just be more than one. Atomic refers to atom. So this is more than one atom that is an ion. So it's a group of atoms that act as one and have a charge. What that means is we have certain ions that are more than one atom chemically combined, but they act like they're just one unit. They act like they're one thing. Here's a list of the common polyatomic ions that we'll be working with. You do not need to memorize this list because you will be given a hard copy. Okay, if you notice, for example, the top half, these are the cations. There's only one main cation that's a polyatomic ion, and that's called ammonium, which is NH4. What that means is NH4 altogether has a charge of +1. Sorry, that's an H, not an A. Okay, so when ammonium reacts, it reacts as NH4. Okay? But if you notice, we have far more anions, so that's really what we focus on. Okay. For example, let's say we have sodium and sulfate reacting. Now this is why in that other video with the transition metals, I showed you guys the crisscross rule, because it's a lot more difficult to draw these polyatomic ions since it's not just one atom, it's multiple atoms. But you guys should know sodium is Na with a +1 charge. Sulfate, notice that it ends in 8. If we come over here to that list again, we need to look through here. Bromate, sulfate is SO4 and it has a -2 charge. So what I want you guys to do, whenever we have polyatomic ion, always, always, always put it in parentheses. That way you know whatever is in parentheses, it has to stay like that. We don't alter it. And it has a charge of -2. Using the crisscross rule from the other video is where we just cross the charges down. The numerical value, not the positive or negative, because now we're just going to be talking about amounts of atoms. We have Na2 and then SO4 1. Just like before, if there's a 1 there, we don't have to write the 1. So we could just have Na2 SO4. Since there's no number outside of the parentheses, you don't even need the parentheses anymore. So it would just be Na2 SO4. So for our next example, we have potassium and hydroxide. Now I know that it ends in "ide", but if you notice hydro and then the ox, or hydrogen and the ox, this reminds one of hydrogen, and of course the OX is going to remind one of oxygen. So if you look back over here at our list, if I look for hydroxide, here it is right here. And I was right, OH. And it has a charge of -1. So, OH, and since it is a polyatomic ion, I'm going to put it in parentheses, it has a charge of -1. Potassium, being in group 1, will have a charge of +1. When you take the numbers and cross them down, you get K1OH1. Again, you don't have to write the ones. So we get KOH. Since there's no number outside of the parentheses, you don't need the parentheses anymore. So it would just be KOH. Okay. The name of this compound is a little bit easier because it is a polyatomic ion. All you have to do is you write the name of the cation as it is. So potassium. And then you just write the polyatomic ion. Potassium hydroxide. Okay. For example, this is the name of the compound, aluminum nitrate. Now we know aluminum is Al. It is in group 3, so it will lose those 3 valence electrons to become positive 3. Now I gotta figure out what nitrate is. Okay, so I look back at my list. Nitrate. Nitrate is NO3. So I have NO3. And I believe it had, yes, -1 charge. -1. So I take the charges, cross them down. So I have Al1, NO3, 3. Okay, don't need to write the ones, so I have Al, NO3, 3. Okay, this means that for every 1 aluminum, I need to have 3 nitrates. Okay, this 3 lets me know there's 3 of whatever is in parentheses. I have to keep the parentheses there, otherwise it'll look like there are 33 oxygens. And that is way too many. So I keep the parentheses there. Alright, calcium and sulfate. Calcium, group 2, will lose its 2 valence electrons to become positive 2. Sulfate was one we did earlier. SO4 with a -2 charge. Okay, so when we cross the charges down of calcium and sulfate, we get 2 and 2. Now remember, whatever's in parentheses has to stay that way. We don't change what's in parentheses. But if we can reduce the other subscripts, do so. Okay, 2 and 2 can both be divided by 2, so we get 1 and 1. We don't need to write the ones, and we no longer need the parentheses since it is a 1. The name of this compound would just be calcium sulfate. Okay. Now going from the formula to the name. I know Li is lithium. And since I have more than 2 atoms, I have lithium, I have P, and I have O. So I have phosphorus and oxygen. What that means is that we're going to have a polyatomic ion. Okay? Li is just lithium. So I need to look for PO4 and see if that's on the list. So I needed to look for PO4, which is right here. And that name is phosphate. So the name of this compound is just lithium phosphate. The name of the cation as it is, the name of the polyatomic ion as it is. This one is going to be a little bit more difficult because, number 1, it's got more than 2 atoms. We have Fe, S, and O, which means I do have a polyatomic ion. I also know that Fe is a transition metal. And remember, for transition metals, you have to tell the charge. But I'll get to that in a second. So I know Fe is iron. SO4, we've already done 2 examples with it. So hopefully by now you recognize it as sulfate. So now how to figure out the charge of iron, which was in that previous video. I take this subscript, cross it up. Take the subscript. Remember, SO4 stays together. We do not break that up. And then I would have Fe plus 3, SO4, it stays together, would be minus 2. I check the list, SO4 is minus 2, that is correct. Since that is correct, then iron is correct. So the name of this compound is iron 3 sulfate. And that's ionic bonding with polyatomic ions.